Dear students, Trigonometry chapter. Understand, you have already attended two lectures. WP1 that you already have. And what we are targeting is maximum 4 lectures for WP1. 2 lectures you have already attended. Now we require 2 more lectures only. Understood? 2 more lectures you will attend and the WP1 will be thoroughly gets over. Understood? Right? So, last time I have sent you homework already. Some of these simple examples we have tried out, as you all know. In today's lecture, lecture number 3, I am going to solve few examples for you, and rest of the few examples I will give you in homework. Understood? તો એક વસ્તુ ધ્યાનમાં રહે તમને. In today's lecture number 3, we are going to target few examples, okay, in lecture number 3. Lecture number 4, okay, sorry. Lecture number 4. Few examples which we are going to target from your WP1. WP1 you already have. First I am targeting example number 18 first. What they have given in sum number 18, I am just reading out the example. You also need to verify from your WP1 if 10a equals to under root 3, then prove that or verify that first option sin square a plus cos square a equal to 1. Second, sec square a minus tan square a equal to 1. Third, 1 plus cot square a equal to sec square a. આવું છે. ત્રણમાંથી I will solve first and third. Second, you can do it by yourself. What is the sum? What they have given here? 10a equal to root 3. Now, dear student, remember lecture number 3. There is nothing here, so we can take 1. What is the formula for 10? Opposite upon adjacent, as you know. Let us decide the two sides of the triangle and when I want to name these two triangles, I will intentionally like to take A there, okay? With respect to angle A, this is opposite side, this is adjacent side, this is the hypotenuse as ever. Now, Opposite means BC. Adjacent means AB. So you got two sides. Opposite you got root 3. And adjacent you got 1. Now dear student, I am not applying the Pythagoras theorem, but if you apply Pythagoras theorem, you will get AC as 2. Okay, now let us find all trigonometric ratios, and my personal guidance is always develop the habit of finding all trigonometric ratios, though there is no demand for it. Understand? Sin A. As you all know the formula, opposite upon hypotenuse. Cosec A, just the reciprocal of this, 2 upon root 3. Cos A, adjacent upon hypotenuse, 1 upon 2. Sec A, just the reverse of the 2 upon 1, ultimately 2 only. Then, as you know, tan A, that is already been given, and cot A, just reciprocalize it, 1 upon root 3. After getting all this, dear student, let us try to prove the first one. What is that? Sin square A plus cos square A equal to 1. What should you do now? First you write LHS. Write in LHS sin square A plus cos square A. Okay. Substitute the value. Sin A under root 3 upon 2 whole square plus cos square A 1 upon 2 whole square. Okay. Now just square it, 3 upon 4 plus this is 1 upon 4. Common LCM as you know. So you got 4 upon 4 cancel. You got 1. You got RHS. LHS equal to RHS. 2 can be proved in the similar way. I am just talking for the third one, where I will first find LHS, then I will go for RHS. LHS first, then RHS. Okay. What is LHS actually? It is given 1 plus cot square A. Let us put the value 1 plus cot square 1 upon under root 3 square. Try to understand it. 1 plus 1 upon 3. Take LCM, 3 1 ja, 3 plus 1 upon 3, 4 upon 3. This is your result number 1. Now you take RHS. What is in RHS? Cosec square A. What is cosec here? Just substitute the values. 2 upon under root 3 whole square turn out to be 4 upon 3. Result number 2. Both results are equal, so you will write therefore this way. From result 1 and 2, you will write LHS equal to RHS. Just look at the sum, dear student. Here, because you have to prove 1, so directly LHS equal to RHS. Here you have to prove two identity, 1 plus cot square A and cosec square A. So you have to evaluate both separately. First 1 plus cot square A, then cosec square A. Evaluate them separately, you will get the answer. Just look for 1 minute before I switch to next example. Okay, just have a look at this. Okay, clear. Let me move for another example. Actually, the examples are not so difficult if you just make your basics clear and concentrate. Understood? So, this is example number 18 we have done. Now, let us take another example. Today, I want to solve at least 3 to 4 examples, and then likewise I want to give you the homework. Okay, let us take example number from your work paper. I want to take 11. What is the sum? Read it. If in triangle ABC 10A equal to 1 upon root 3, then find the value. There are two options. I am just taking the one option only. Second one, you can do it yourself. What is that? Find the value of sine A into cos C plus cos A into sine C. See, dear student, the example is not so complicated but demands your attention. Okay, 10A. It is given 1 upon root 3. What is the formula for 10? Opposite upon adjacent, as you know. Just like in the previous example, just a simple triangle is going to help you. Here is A, B and C, the simple triangle. With respect to A, this is opposite, dear student, and this is adjacent. Opposite, that means BC, adjacent, that means AB. BC you got 1, this you got root 3, and as usual hypotenuse you will get 2 when you do it by Pythagoras. Now, dear student, here in this case, you are looking for the value of cos sin A into cos C plus cos A into sin C. Initially, in the first example, I guided you to find all trigonometric ratios, but here don't work unnecessarily. Why you find cot A, sec A, cosec A when they are not in actual demand of the sum? You just want sin A, cos A, cos C, sin A. That is what you want. Now, dear student, concentrate very much. First, I am going for sin A. What is the formula of sin A? Opposite upon hypotenuse. With respect to A, This is opposite, this is hypotenuse. So we got 1 upon 2. Let me find cos A also, because it is also the required demand of the sum. Cos A adjacent upon hypotenuse, root 3 upon 2. Now we also need both the trigonometric ratio in terms of C. So dear student, when you target C, this will be opposite and this will be adjacent, mind. So sin C opposite upon hypotenuse under root 3 upon 2, and cos C, when you are targeting angle C, this is adjacent and this is hypotenuse, as you know. So 4 ratios has been found out, which was actually the demand of the example. I haven't an unnecessary harassment to find all trigonometric ratios here, which were not in just the demand of the sum. So don't look for that, okay? Now, dear student, the value you have to find, that expression I am writing, sin A into cos C plus cos A into sin C. I have just taken one option only. Let me put the value sin A, that's 1 upon 2, cos C 1 upon 2, cos A root 3 upon 2, sin C root 3 upon 2. Okay, now no cancellation, just multiplication. 1 upon 4, root 3 into root 3, 3 upon 4, common LCM 1 plus 3 upon 4. So this is going to be 4 upon 4, and you got the answer 1, okay? This way actually you got the evaluation, understood? Dear student, also mind one very important thing. Whatever the value of 10 may be given, but this should remain a constant identity. Sin A into cos C plus cos A into sin C always equal to 1. આ 1 જ આવે. પછી tan A, cot A ગમે તે વેલ્યુસ આવે, પણ આ ફિક્સ જ હોય. બી રાઇટ એંગલ હોય ને એટલે ફિક્સ. sin A cos C, cos A sin C equal to 1. તમને બોર્ડ એક્ઝામમાં કન્ફ્યુઝ કરવા એવું પૂછી શકે, એમ કે in triangle ABC, angle B is a right angle, then sin A into cos C plus cos A into sin C equal to dash. One જ answer આવે, યાદ રાખો. One very important objective you will find nowhere in any reference book. What I just spoke, if in triangle ABC angle B is a right angle, then sin A into cos C plus cos A into sin C equal to 1. Mind this very important identity and take a serious note of this. Okay. So this is example number 11 we have done. Okay. Now dear student, let us go for one more example, and this is like this. Example number 12, let us do. First you read that particular example. If tan theta equal to 4 upon 3, then find the value of 5 sin theta plus 2 cos theta upon 3 sin theta minus cos theta. See dear student, tan theta is given. You all know very well the formula, opposite upon adjacent. Here theta is given, So you do not need to concentrate on particular angle, but simply saying you can take theta here. This will be opposite, this will be adjacent. So opposite, that is AB, adjacent, that is BC. You got this 4, these 3, and by Pythagoras you will get the hypotenuse. Now in the required, which trigonometric ratios you need? Only sine and cos. Let us find sine theta. Opposite upon hypotenuse. Okay. Cos theta. Adjacent upon hypotenuse. You got it. And which expression we have to evaluate? Let us write it first. It is, please concentrate here, 5 sin theta plus 2 cos theta upon what is given in the example 3 sin theta minus cos theta. Okay, first you write this. Let us substitute the value. This is 5. What is sin theta, dear student? 4 upon 5. 2. What is cos theta? 3 upon 5. Upon 3. What is sin theta? 4 upon 5 minus cos theta 3 upon 5. I will just carry on one step here and rest there. Even 5 is cancelable, don't cancel. Just multiply because we need common denominator everywhere. So just multiply 5 4 ja 20 upon 5 plus 2 3 ja 6 upon 5 upon 3 4 ja 12 upon 5 minus 3 upon 5. See, dear student, everywhere we got common denominator J everywhere. So in denominator I will like to write 220 plus 6 upon 5, and here, dear student, I will write 12 minus 3 upon 5. So I got as a result 26 upon 5 upon 9 upon 5. Let us cancel. So you got the answer 26 upon 9. Just have a look at the sum. This example hasn't been in your textbook, but from other old textbook and reference book I have included in WP1 for some more practice. You just verify this. Okay. And still one more example, dear student, I want to take. Here for explaining you that we will get the common denominator and the solution becomes simple. That's why only now one more example I would like to target. Okay. One more example also let us see, and that is your example number from WP1 8. What is given there? I am just writing the basics. Cot theta is 7 upon 8, and you are looking for the value of, read it, 1 plus sine into 1 minus sine upon 1 plus cos into 1 minus cos. Now, dear student, my guidance is here 1 identity also can be applicable here. And if you want to go rather than remembering the identity as per the basics, then also it's okay. I would like to move as per the basics rather than remembering identity. That is our type 4 when we do cot theta. You all know the formula, opposite upon adjacent upon opposite, okay? Suppose this way, a triangle has been constructed ABC and I would like to take theta here, okay? This will be opposite side for me with reference to theta. This is adjacent, this is hypotenuse. Adjacent, that means BC. Opposite, that means AB. So BC you got 7 and this you got 8. Now if you just go for the Pythagoras, suppose AC square equal AB square, so 8 square 64, 7 square 49, 9 plus 4 13, 113. So this will be under root 113, okay? What we actually require, we require sine theta, that is opposite upon hypotenuse, okay, and one you require cos theta, that is adjacent upon hypotenuse, right? Now what you are targeting to evaluate, let us write it. 1 plus sine theta into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta. This is what you need to evaluate. Now dear student, a little logic of expansion. A plus b, a minus b. So a square minus b square, 1 will be a, sin theta will be b. Can I write this way? 1 square minus sin theta whole square. Similarly, 1 plus cos theta into 1 minus cos theta. Can I write this way? 1 square minus cos theta whole square. This is going to be 1 minus sin square theta, and this is going to be 1 minus cos square theta. Now let me substitute the value. I just carry on the sum here. 1 minus sin square theta, 8 upon 113 whole square, 1 minus cos theta, 7 upon under root 113 whole square. Let us simplify. 1 minus 64 upon 113, 1 minus 49 upon 113, LCM, first in here, 113 minus 64 upon 113, 113 minus 49 upon 113, this is cancelled. 113 minus 49, 13 minus 4, that is 9, here is 0, okay, 10 minus 6, that is 4, and here 13 minus 9, that is 4, 10 minus 6, that is 10 minus 4, 64. So this is the answer you got. Okay, dear student, just look at the sum. This way, some little modification. Okay, so what is my target, dear student, in today's lecture? We have taken 4 examples, all were getting the values and proving them. Understood? Now you need to study all these examples very consciously And in homework, dear student, the sum I am writing, this is your homework for today. Okay, just don't do homework to just show me. Do homework so that you can master this type. Example 8, 9, 10, 11, 13, 16 and 18. This is your homework. 8, 9, 10, 11, 13, 16 and 18. Few of the examples I have already calculated here for you. But you also need to just when you do in homework the same example, first you need to practice them thoroughly and then you produce me in the homework. As dear student, I already reminded you. This is the basics of trigonometry. And if these basics are not clear, you may find it very difficult to cope up with the other examples later on. So make it very strong. You need to understand the topic very well. Okay, don't think like that the whole year has passed it this way offline means the board paper will come simpler. That is not going to happen. It is going to come as ever they come, little complicated, little average, easier. So you have to prepare yourself thoroughly to score very high in the exam, and I don't think I need to remind again and again for the homework. Okay, please be very punctual in your homework, right? Thank you very much.